So in this video we're going to work with the first titration experiment in the water chapter, which is to calculate the total hardness found in a sample of water. You can take the sample of water from anywhere, and we're going to use a chemical called EDTA, or ethylene diamine tetraacetic acid, and we'll talk about that a little bit more soon. So normally in water we have deposits. In water we have calcium ions and we have magnesium ions, which run in off the ground into the water, and it's these ions that cause the hardness. Now for our experiments there will be calcium ions and magnesium ions in the water, but this particular experiment is only to detect the calcium ions, and the calcium ions come from CaCO3. So we're just, although there is magnesium ions in there, we're just concentrating on the calcium ions at the moment. Here's the basic setup that you've seen already. You've got your basic titration setup. Your EDTA goes into your burette, and then at the other end in your conical flask you have your sample of water from wherever it might be. You add in aerochrome black tea, which is your indicator, and that's got a wine red colour. You also put in a buffer solution, and the buffer solution keeps it at a pH of 10. You titrate in the usual manner until you get a colour change. The colour changes from wine red to blue, and you repeat the experiment then to get within 0.1 cm cubed of two results that agree with each other. So that's the basic setup. It's a simple titration just with different chemicals. So a couple of things about the experiment that you need to know. Well, first of all is EDTA. Now I mentioned already that it was ethylene diamine tetraacetic acid, and you need to know this for your leaving cert. So you need to know the name, the full name. I've split it up into separate words here: ethylene, diamine, tetra, and acetic. But it is actually all one word, with the exception of the acid at the end. The ethylene diamine tetraacetic is all one word. You have to know that for leaving cert. You don't need to know the structure, just the name. And again, hardness, when you're working this out, the hardness of the CaCO3 in this is going to be measured in milligrams per litre. Of course, when we're doing this, this is going to be milligrams in 1000 cm cubed, which is 1 litre. Once you have it in milligrams per 1000 cm cubed, you can just rewrite the number as ppm, or parts per million. And traditionally speaking, numbers are written in parts per million when you're talking about concentrations in water, especially of calcium carbonate. So here's the basic idea of your range of values. So if you have over 300 parts per million CaCO3, that means you've very hard water. In other words, you've got a large amount of calcium ions. This does not take into account magnesium ions, but just calcium ions. If you're between 150 to 300 parts per million, it's hard water. 75 to 150, slightly hard water. And then if you're below 75 parts per million, that's classed as soft water. So a couple of notes then about the titration. So you're basically mixing water with EDTA, and it's the water that contains the calcium and magnesium, but it's actually the calcium and the magnesium that are reacting with the EDTA. It's just the water as a source of these. Your indicator is aerochrome black tea, which also has another name called solochrome black, and you may come across that as well, but more commonly known as aerochrome black tea. It's a wine red colour, and the colour change you need to give before and after wine red to blue. If you get a blue colour in the experiment, that indicates that all the calcium and magnesium in the water has now bonded to the EDTA, and that's the point of the EDTA solution. The EDTA solution actually surrounds the calcium and magnesium ions, and that's what's called a complexometric titration. So you may come across that as well. The calcium and magnesium will only react with EDTA at a pH of 10. So this is important. This reaction will only happen at a pH of 10. Now water, depending on what you've got, has got a pH of about 7 or 8. So we need to adjust the pH and make sure that the pH stays around 10. To do that, we add a buffer solution. So our buffer solution, which is here, will keep the pH at around 10. Some of you may have used this in biology or ag science. That's the main points for that experiment. Now what we're going to do is the harder bit. We're going to look at the maths bit and look at the calculations. So we've got a sample of water. It was analysed, and as usual what I would do is I would take some time and go through this and identify the information that's important to us. It says 50 cm cubed of water were placed in a conical flask, and some buffer solution and aerochrome black tea indicator were added. The solution was titrated against a 0.01 molar EDTA solution, And the average titration figure was 15.2. And you're asked to calculate the total amount of hardness in the water. So if we're asked to find the total amount of hardness, well then that's going to be ppm. We need to find that, or we need to find the amount of milligrams per litre. So I left a little bit of the answer in there. The EDTA complexes with calcium and magnesium ions in the ratio 1:1. So calculations involving EDTA, the mole ratio is always 1:1. So sometimes you may not get the actual equation in this, so you have to know that it's 1:1. Okay, so let's have a look at this. So generally, the best thing to do is to work out our M1V1. So we've got our M1V1 over N1 is equal to M2V2 over N2. So one side is going to be the water and the other side is going to be the EDTA. So the water is going to be your calcium ions in this scenario, M1, V1, N1. I'm going to have to fill in all the numbers. So based on the numbers, we've got the molarity of the calcium, the volume of the calcium, and the number of moles for the equation. So we're already told it's a 1:1. So that means the number of moles in the bottom is going to be 1. We're also told in the question that we have 50 cm cubed of water, 0.01 molar EDTA solution, and 15.2 was our average titration. So we can fill those numbers in. So we don't have the molarity of the water, in other words, the concentration of the Ca2+. We don't have that. So it's going to be M1 multiplied by the volume. So the volume of the water we were using was 50 cm cubed. And on the other side, we have the molarity of the EDTA, which was 0.01, multiplied by the volume of the EDTA, which is the average titration, which was 15.2. So with a bit of maneuvering of the equation, you end up with M1 then is going to be equal to 0.01 multiplied by 15.2, all divided by 50. So you end up then with M1 is going to be equal to, I worked it out here, as 0.03. Now, that is molar because it is molarity. So once we see molar, we can change that to 0.03 moles in 1000 cm cubed. And that's your CaCO3. So that's what we're dealing with. Now, the thing about this is we're looking for parts per million. So parts per million is milligrams per litre. So we actually have moles per litre. So we're going to have to try and change this moles into grams. So the first thing we're going to do is we're going to multiply by the molecular mass of CaCO3. So if we take CaCO3 and we work out the molecular mass of it, molecular mass works out to be 100. So what we've got to do is we're already at moles, we need to go to grams, so we're going to multiply by the molecular mass, which is equal to 100. So when we do that, you're just going to get 0.3. So now we have 0.3 grams in 1000 cm cubed. But again, we're not looking for grams per cm cubed, we're looking for milligrams per 1000 cm cubed. So to get to that, you're going to have to multiply by 1000. So multiplying this by 1000, and that's to go from grams to milligrams, then you're going to end up with 300. So you end up with 300 milligrams in 1000 cm cubed. So that's 300 milligrams per litre. So that is 300 parts per million. And 300 parts per million would indicate, from everything we've done so far, would indicate that this is very hard water, 300 parts per million. So this is very hard water. And that there will be your total hardness. So that's the basics of the maths. Now what we'll do in the next video is we will have a look at some Leaving Cert questions just on this.